Okay, so what if they were to give you a graph and it looks like something like this? Here's your x-axis and here's your y-axis. You'd have to use your imagination on some of those numbers. What if they came in here and they did this? Now I've got one of each, don't I? Okay, so let's talk about domain first. What does the domain represent? My x's. Make sure you're watching, not doing something else, okay? Because otherwise you're not going to know what to do. This is not in a book anywhere. You have to listen to the lecture. Okay? So if I want to list that, I'm talking about my x's. Now I can't really show you this, on the iPad, but what is the lowest x that I come to? If I'm going across the x-axis like this, 1. So that's one of my boundary points. As I go across, what's the highest one it looks like it goes to? We're going to say 4. I'm sure I didn't draw it greatly. Now, all my x's are smushed between 1 and 4. Am I going to draw a line under the arrow right here beside the one I'll highlight it? This one right here, do I put a line underneath it? Make them listen, okay? Come on, listen. Everybody listen. I don't. Why not? It's an open circle, so I'm not going to put a line there. No line by the one, because it's an open circle. That's why I wanted you to listen, okay? No, I drew one open and one closed so that we could have this discussion, okay? Because just to make sure you understood. So I'm not going to put one by the one because it's an open circle. But what about the 4? Am I going to put a line under the 4? Yes. Why? It's a closed circle. It's colored in. So I will put a line on that one. Okay, that's the domain. The range is the y values. So would you agree with me that my y values are sandwiched in between 2 points, 2 parts, 2 different values, right? So y goes up and down. As I move my imaginary ruler up from the bottom, what's the lowest y value I hit? 1. So that's going to go here. Is that 1 colored in or open? It's open. So am I going to put a line under that inequality sign between 1 and y? No, because I don't want to count that. That's not really a point. It's a boundary, but it's not counted because it's not colored in, so I don't put a line there. Now, as I move my imaginary ruler up, what's the highest one I hit? It's supposed to be 4. Probably can't tell. 4, okay. Am I going to put a line under that 1 by the 4? Why? Yes, is correct. Why?
Because it's colored in.
It's colored in, so I do put a line. Y'all see how that works now? Okay, so sometimes it helps to see one of each, I think, and we didn't get that on this graph. Now, here's another thing. They have been asking us, are these functions? Let me put, is this a function? You can kind of think about taking your ruler now and moving it across. If you move your ruler across, does each x value you hit only hit 1 point, only hit 1 y value? It does, doesn't it? These are functions because each x value only has 1 y value. There's a quick way to do this, and it's called the vertical line test. You learned about this usually sometime this year. I don't know that your book talks about it, though, so we need to talk about it. The vertical line test says if I go through and I draw a vertical line, I should only hit 1 point anywhere I draw it. If that happens, I have a function. So this is a function, isn't it? Because no matter where I draw it, I'm only going to hit 1 point. So this is a function. I would put yes. Here's one that's not a function. I had a graph of a parabola, and it was facing sideways. If I come through here, if I pick an x right here, it has a y value, it has a point here, so that's 1 y value, but doesn't it have another y value right above it? If I drew a vertical line, how many points am I hitting on that graph of that Let me do a different color because it's not showing up with that yellow. How many points did I hit on the graph? 2. I'm not counting the axis, by the way, in case you're wondering. I'm just counting the blue graph. I hit 2 points here and here. That means this x value right here has 2 y values that go with it, so this one would not be a function. Not a function. Here's another one.
On number 3.
Hang on a second. I'm in the middle of something else, okay? Because we kind of went way past. Hang on a second. We got a circle.
It has to do.
Okay, just a second. Let me get through this and then I'll answer it, okay? So if I were to do a vertical line, it's called the vertical line test. How many points did I hit on that circle? 2. Just because I hit 2, that makes it not a function. Okay, what were you asking about number 3?
It says it's
Get 4.3. The idea, one of the new ideas that they add in here is the idea of an independent value and a dependent value. And actually, you have this in your notes already, don't you? Because remember when we made the giant x comma y? And we talked about all the different ways that we could talk about x and y. One of the ways for x was domain. But do you remember that another way we could refer to the x is the independent variable? Remember, we wrote that on our notes yesterday, right? The independent variable is the variable that I can change easiest, is the way that I guess I would say it, that I can easily change. For instance, if I have an equation y equal x plus 2, isn't it easier for me to put an x in there and tell you y than it would be if I gave you y is 5. Oops. If y was 5, wouldn't I have to kind of do some subtraction stuff in my head to kind of solve a little bit to get the x value? Usually the independent value is the one that we plug in. Okay, so like I would plug in x and I would get out y. Y would be my output, but we also call it the dependent variable because it depends on what I plug in for x. Okay, so if you're, we had this on our notes already. It's not like this is new stuff, right? This was actually what we put in yesterday. All right, so if you look at practice A, the side is like page 19 at the bottom. It says, go down to number 4. Auto insurance increases with each accident and traffic violation. The cost depends on how many accidents or how many traffic tickets. I'll put how many accidents, tickets, misspelled accidents, that I get. So therefore, which is my dependent variable? The cost. So out beside cost, we're going to write dependent because it depends on how many tickets and accidents I get into. If I don't get into any accidents and I don't get any tickets, my insurance theoretically wouldn't go up. So since cost depends on the other, that means that this other one is my independent variable. It's almost easier to identify the dependent variable and then know that the other one's the independent. If I want to think about this, I want to think blank depends on blank. Does the number of DVDs I purchase depend on the cost? Or does the cost depend on the amount of DVDs I purchase?
The cost depends on the amount of DVDs.
Does everybody agree? Cost depends on DVDs, on number of DVDs purchased. Okay, so you see it's really kind of common sense, but why is this important? If I were to go graph this, my independent variable goes on the x-axis and my dependent variable goes on the y-axis. So this is more important than just labeling and going, oh good, I labeled it, now let's go on. It would help me know if I had a word problem, how to graph it. If I were to find an equation, how would I put this on the axis? So total cost is my dependent, and then this is my independent. So if I were to graph this, I'd want to put the number of DVDs I purchased. That would be like what I would put here, 1, 2, I bought 3, I bought 4. And then my cost would go on my y-axis. That's how you determine when you graph things. That's why we're talking about it, is because we're going to be graphing a lot the rest of the semester, and this week we're just kind of getting started on that. So this is why we're talking about it. So what depends on what in this example?
The sales depend on the temperature.
Sales depend on the temperature. If it's hot outside, I might sell a lot of ice cream, but if it's one of those, if we lived in Boston right now, I don't know if y'all seen pictures of Boston on the news, they're just buried under snow. Do you think they're probably selling a lot of ice cream in Boston?
Not really.
Probably more coffee, hot chocolate, warm things, maybe Mexican
I don't see how they
food.
can sell anything.
That's true. I doubt they can get out of their houses.
When I went to New York,
So what we're going to do here is just say our independent variable is the temperature. Here's another way to look at it. Can I control the temperature?
No.
No, not really. God kind of controls the temperature, I guess, or, the weather patterns. And then, but what depends on the temperature is the sale of ice cream. If it's hot, I might sell more, especially like think about being at the zoo or a theme park and you're hot, it's the middle of summer, ice cream might sound kind of good at that point.